The post-perihelion images of Atlas just dropped, and what they show raises questions scientists are struggling to answer. The massive cometary tail that should be there isn't. Let me show you why this is extraordinary, and why the natural explanation for Atlas's behavior just hit a major obstacle. Two new images of Atlas were released yesterday by the Virtual Telescope project, and when you look at them, when you really examine what you're seeing, something is deeply wrong. Atlas appears as a compact source of light, no massive tail, no enormous diffuse cloud of gas and dust, no dramatic expansion of material streaming away from the nucleus, just a compact bright point, almost unchanged from how it looked back in July. Now, let me show you what should be happening, and this is where it gets really interesting. On November 3rd, just 2 days before the Atlas images, the Naves Observatory in Spain captured an image of Comet Lemon. This is a normal comet from our solar system. Nothing unusual about it. Standard cometary behavior. Look at Lemon's image. See that clear? Brilliant tail pointing away from the sun? That's what comets do. That's normal. That's physics working exactly as expected. Solar radiation pressure and solar wind push gas and dust away from the comet's nucleus, creating that characteristic tail that always points away from the sun. It's one of the most fundamental, predictable features of cometary activity. Now look at Atlas, compact light source, no comparable tail, no massive outflow of material. These images were taken just 2 days apart, same time frame. Same solar conditions. One shows normal cometary behavior, the other doesn't. And here's why this matters so much. NASA's Jet Propulsion Laboratory confirmed that Atlas is exhibiting non-gravitational acceleration. Something is pushing this object off its purely gravitational trajectory. If that push comes from natural outgassing, from ice sublimating into gas and creating thrust like a rocket, then Atlas must have lost at least 13% of its total mass during its perihelion passage. 13% of a 33 billion-ton object. That's over 4 billion tons of material ejected into space in about 1 month. When you lose that much mass through sublimation, when billions of tons of gas and dust are released, you don't get a compact light source. You get exactly what we see in Comet Lemon. A massive tail, a huge diffuse cloud, material streaming away under solar pressure. The physics is straightforward. Release massive amounts of gas. Solar radiation pushes it into a tail. That's how comets work. That's what we see in every natural comet. That's what Lemon shows us on November 3rd. But Atlas on November 5th, compact source, minimal tail. Morphology, not very different from the Hubble Space Telescope image captured back on July 21st. Think about that timeline. July 21st. Atlas looked a certain way, then it went through. Perihelion, on October 29th, experiencing maximum solar heating, supposedly losing 13% of its mass, and now on November 5th, it looks almost the same. No dramatic change, no massive expansion, no enormous tail that would indicate billions of tons of freshly released material. This is the test we've been waiting for. If Atlas's acceleration comes from natural outgassing, the post-perihelion images must show massive cometary activity. They must show what Lemon shows, clear evidence of substantial material loss. The November 5th images, they don't show that. And this creates a puzzle that conventional comet science is struggling to explain. You can't have confirmed non-gravitational acceleration requiring 13% mass loss without the visual evidence of that mass loss appearing in observations. It's like seeing a car accelerate down a highway, but finding no fuel being consumed. The acceleration is real. The measurements are confirmed. But the expected consequence, the thing that should be obvious and unmistakable, isn't there. Now, Let me be clear about what we're saying here. We're not claiming definitive proof of anything. We're presenting observations that raise serious questions. The images show Atlas as a compact source without the massive tail expected from 13% mass loss. That's observational fact. NASA's JPL confirms non-gravitational acceleration requiring that mass loss. Also fact. The puzzle is, how do you reconcile these two facts within conventional comet physics? Some scientists might argue the tail could be oriented in a way we're not seeing clearly, or that the material is there but not visible in these particular observations, or that there are measurement uncertainties we haven't fully accounted for. Those are possibilities. Science requires considering all explanations, but here's what makes this significant. We now have a side-by-side comparison. Comet Lemon on November 3rd showing normal behavior. Atlas on November 5th showing something else. Same time frame, same observation conditions. One behaves as cometary physics predicts, the other doesn't. And Atlas has been doing this for months. 10 documented anomalies. Trajectory alignment, industrial metal ratios, wow signal direction, blue color, non-gravitational acceleration. And now, post-perihelion images that don't match the expected aftermath of massive outgassing. Each anomaly individually might have an explanation, but collectively, they form a pattern that challenges conventional understanding. The November 5th images add to that pattern. They show an object that's accelerating without displaying the visual signature of the process that should be causing that acceleration. It's worth noting, we're still waiting for NASA to release the highest resolution images ever taken of Atlas. The HiRISE camera aboard Mars Reconnaissance Orbiter captured Atlas on October 2nd with 3 times better resolution than Hubble. Those images remain unreleased. Despite requests from scientists, despite an official letter from Congresswoman Anna Paulina Luna, despite the clear scientific value of the data. So we're analyzing what we have? The Virtual Telescope Project images from November 5th, the comparison to normal Comet Lemon from November 3rd, the JPL data on non-gravitational acceleration, the calculations showing 13% mass loss should be required, and what we're seeing raises more questions than it answers. Where is the massive tail? Where is the billions of tons of ejected material? Where is the visual evidence of the process that conventional physics says must be occurring? The images show a compact source. The acceleration data says massive outgassing. These two facts are difficult to reconcile. This is the puzzle. This is what has scientists debating. This is why Atlas continues to defy easy categorization. We're not declaring answers. We're presenting observations that demand explanation. And right now, the conventional explanation is struggling to account for what we're seeing, or more accurately, what we're not seeing. The test was clear. Show us the massive cometary activity, post-perihelion. Show us the tail. Show us the evidence of 13% mass loss. The November 5th images, they don't show it. More observations are coming. More data will be collected. More analysis will be conducted. And perhaps conventional comet science will provide a satisfactory explanation for why Atlas accelerates, like it lost billions of tons of mass. But looks like it didn't. Until then, the puzzle remains. The questions persist. And the images from November 5th have made the mystery deeper, not clearer. Share this, because people need to see the side-by-side comparison. People need to understand what normal cometary behavior looks like and what Atlas is showing instead. The images are public. The data is official. The puzzle is real. And we're watching it unfold together, waiting for answers that make sense of what we're observing. The test failed. The massive tail isn't there. And the question remains, if natural outgassing didn't create the acceleration, what did? Stay tuned, because this story is far from over.